Every second, billions of tiny decisions are made by machines, thanks to something called digital logic. At the core of this digital universe lie the basic building blocks: logic gates, not, and, or, and their clever cousins like NAND, NOR, and XOR. Simple, huh? Yes, but without them, no smartphone, computer, or rocket would exist. To design these digital brains, we used a powerful tool, the FPGA, a chip you can reprogram to do almost anything. And in order to speak to the FPGA, we use a language, Verilog, the coding language of digital hardware. In this video, we'll dive into writing Verilog code using Xilinx Vivado to create logic gates from scratch, test them with a test bench, and simulate their behavior, all in real time. In Vivado, use Quick Start to create a new project. Choose your desired name and project location to save your project. Don't forget to check Create Project Subdirectory. And this is an RTL project because we are starting the project from scratch. And you do not need to specify sources at this time. We are going to add them to project later. And choose your own FPGA. Mine is an RTX 7 general purpose FPGA. You choose your own. Great. And here is the project summary. Nice. Now we are going to add sources to our project. First, we add design source. This is our .v file, and I'm going to call it digital gates. And here we need to specify I/O pins. A and B are our input pins, and we define outputs for NOT gate, AND gate, OR, NAND, NOR, XOR, and XNOR. Don't forget to set direction to output for them. Great. And here is our .v file. As you can see, I/O pins have been specified. Now let's complete our module. Use assign keyword in Verilog to derive your output variables values. And you can see we are defining our digital gates here by digital gate symbols. And this little green box here indicates that there is no syntax error. If it was red, it meant there is something wrong with your syntax. Now let's write the test bench. To do that, add source, we need to add simulation source. And I'm going to call it TB digital gates because it is a test bench. You don't need to define I/O pins here. And in the simulation sources file, we can see our test bench file has been generated. Great. We need to define inputs as register and outputs as wire. This is because we need the FPGA to remember its inputs, and the outputs are just functions of inputs and they change as soon as the inputs change. Great. Now we need to define unit under test. To do that, copy your module name and paste it in your test bench and then write UUT, which stands for unit under test. Then we need to connect our test bench signals to our module signals in the way that you are watching. Great. Now we need to define our inputs. First, we set both A and B to 0 and then wait for 10 nanoseconds. How do we know that we are waiting for 10 nanoseconds? So, as you can see here, the time scale is 1 nanosecond and its accuracy is 1 picosecond. And do it for other situations like when B is 1, A is 1, and both inputs A and B are 1. And by writing $finish, we tell the simulator that our simulation has finished. Now we can run the simulation, and here we can see the result. As you can see, when both A and B are 0, A0 is 1 and 0 or 0, 1, NAND 1, NOR 1, XOR 0, XNOR 1. When just B is 1, again A0 is 1 and 0 or 1, NAND 1, NOR 0, XOR 1, XNOR 0. And when just A is 1, not 0 and 0, and you can see the other results in your display. And you can check whether your code works fine or not. You could also run the synthesis and see whether the FPGA can synthesize your code or not. And here you can see the result of your code, if interested. You can also open the elaborated design to see the RTL analysis, and here you can see the gates you have written the code for, see your inputs, outputs, etc. And if your FPGA board is available, in this section you can program your FPGA. If you enjoyed watching this video and find it helpful, don't forget to like it and subscribe to our YouTube channel for more videos. If there are any questions, feel free to ask me in the comment section. Good luck!